over gas law units of measure. Here's where there's a problem. Let me hold this moment. P, pressure. Hold that thought. Okay. Because for some problems, we really don't have to convert the volume of milliliters into liters. Okay. However, you're not going to know when you should convert or not. So here's what I said. Okay. Pressure, let me talk about that in a second. Okay. Volume should be in liters. Volume could be in milliliters, convert it to liters. Volume must be in Kelvin. Kelvin. You're going to have degrees Celsius, okay? However, all the theory, the kinetic molecular theory, etc. for gas law is based on a concept of absolute temperature. And absolute temperature is measured in kelvins. They're not degrees, just kelvins, okay? So if you have Celsius, change it to kelvins, period. Now, N, of course, is number of moles. Now, this is not difficult. You're going to have milliliters converted to liters. Temperature, also not difficult to convert. Kelvins equal the degrees Celsius plus 273.15. Super easy. Easy to do, also easy to forget. You must convert to kelvins, period. N is number of moles. So if you have grams, you must convert them to moles. We're going to talk about this a little later. Now, here's the bugaboo with gas law units, and that has to do with pressure, okay? Pressure can be measured in atmospheres, ATM, pascals, PA, kilopascals, KPA. They can be measured in a unit called torr, after a scientist, Torricelli. He made the first barometer, so in his honor, torr. They can be measured in millimeters mercury, centimeters mercury, or PSI, pounds per square inch, okay? What a pain. Often when you encounter gas law problems, they're going to be in one of these units, okay? Here's what we're going to do. We are going to use KPAs. I know more recently, some of the science teachers are going to KPAs. We are going to stick to atmospheres, okay? The reason we're sticking to atmospheres is then when you do R, which is 0.082 atmosphere, liters, moles, Kelvin, okay? You don't have to think about it. There's a different value for R if you're using PSI. There's a different value for R if you're using KPAs. I want to remember one value for R, so I'm going to use atmospheres because 0.082 has, again, we can use that number when we're using atmospheres, liters, moles, Kelvin. Okay. We use this with another equation called the ideal. So hold that thought. Let me go back to pressure. So here's the problem. Pressure can be in atmospheres, pascals, kilopascals, torr, millimeters mercury, centimeters mercury, PSI. Let me show you the conversions. We're not going to do anything with PSI. 0. One atmosphere, I'm telling you what it is, but we're not doing it. One atmosphere is also 101.3 kPAs. A kPa is 1,000, PAs pascals. So a kilopascal is 1,000 pascals. An atmosphere is equal to 760 millimeters mercury. Okay, so an atmosphere is also equal to 14.7 psi. Now, delete that from your vocabulary. We're not going to do anything whatsoever with psi. Okay, this is bad enough. An atmosphere, it's 760 millimeters mercury. It's also 760 millimeters. It's also 760 torr. They use millimeters mercury, and torr almost interchangeably. They're all 760 in one atmosphere. And of course, then one atmosphere would be 76 centimeters. Jot this down. Most of the time, we're going to have kPAs given that we have to convert to atmosphere, or we're going to have something like millimeters mercury. Occasionally, you see centimeters, okay? So these are the units, and it's the pressure that's the big pain. So you need to convert atmospheres, liters, moles, Kelvin. Kelvin always. Okay, that's it for this one.